So it's just important that, when it comes to these questions where they're talking about speed, position, think of it in this way. Ask yourself that at this point there, right? If that function is um, is representing speed, okay, then ask yourself that if I'm at this point there, my speed is 0. If I'm starting off, okay, you haven't started moving, so my time is 0, my speed is 0. Then remember, okay, this is a graph that represents speed as well as time. Now, if I'm traveling, okay, how do I get my maximum speed? Okay, we are thinking back to what? We are thinking back to our quadratic functions. Okay, how do you get the maximum or the minimum of your quadratic function? It's the turning point. Okay, you just want to determine what is that y value of the turning point. In this case, it is a maximum, right? Because we've got a negative, okay, a. Then from there, you think to yourself, oh, at that point there, where they stop, because you gotta stop at that point because you've reached your destination. Okay? Right? So the speed is equal to 0. What is the total time that they had traveled? Right? So to determine the time there, you obviously need to then make use of the initial equation for speed. Okay? The initial equation for speed, which is s prime t, okay, to help you determine if my speed is equal to 0, right? If my speed is 0, what is the time, right? And then you'll get 2 times, right? And obviously it makes sense because we do have 2, x-intercepts there for time, right? We've got that when t is equal to 0, and we've got when t is equal to something that we need to, figure out. Okay, and we found that, oh, it's when t is equal to 6, right? Then from there we know that, oh, it takes them 6 hours to travel from point P to point T, right? Therefore now, going back to that position formula, you just substitute T to get now how far these 2 towns are from each other. Okay, right? So you need to practice. I think maybe we should do